Good afternoon, good morning, or good evening, depending on where you are in this world. And welcome to today's DevOps.com webinar. I'm your host, Charlene O'Hanlon, and I am the moderator for today's event. Okay, but before we get started on today's webinar, I have a few housekeeping things to go over. First of all, today's webinar is being recorded. So if you miss any or all of the event, just know that you'll be able to access the webinar online following the event. We'll be sending out a link via email, and the webinar will also be available on the DevOps.com website. And we are taking questions from the audience, so at any time during today's event you have a question, feel free to use the control panel on your screen to submit your question. We'll take about 15 minutes near the end of the webinar to go through the audience questions. Okay, with that, we'll go ahead and get rolling on today's webinar, From Good Code to Great Code, Why Developers Need to Own Application Security, sponsored by Veracode. Our speakers today are both, I believe, are no strangers to the DevOps.com webinar sphere, if you will. First one is Tim Jarrett. He's the Senior Director of Product Management at Veracode, and I believe he is the only Grammy winner to speak on a DevOps.com webinar. And our second one is Matthew Runkle, who's Senior Security Consultant at Veracode. Welcome to you both, guys. Thanks for being here.
Thanks so much for having us.
Great. Well, I'm just going to go ahead and turn it over to you guys and let you do your thing.
Thanks very much. So with that introduction, we'll dive right in. The purpose for today is to take a look at some of the latest data that we have from our the application security testing that our customers have been doing, and which represents a very large chunk of the application security testing happening in the market today. From that testing, we're going to draw some conclusions both about the security of applications and about the ways that developers think about security. You know, I'll do one more slightly deeper round of introductions so that you can understand why Matt and I are both talking to this today. I have been not only at Veracode for almost 10 years. Long story about the Grammy Award thing. If you want to ask, you can tweet me later. And there's my bacon number connection, the Seinfeld soup Nazi. But more pertinent for this discussion is that I've been on the software development side for pretty much my entire career as both a software developer and a manager before becoming a product manager. And so looking at security from the perspective of the development side is something that's near and dear to my heart, and I think really to the hearts of everybody at Veracode. And with this year's State of Software Security report, we got a chance to dive in a little bit deeper on how developers think about the security problem and what that translates to in terms of how secure applications really are before development teams start to adopt application security more formally. And we asked Matt to join the call for a very specific reason, which is that Matt spends most of his time at Veracode working with development teams. And Matt, do you want to say hello and say a word about kind of that role?
Sure. Yeah. Hi. My name is Matt. I've been in the security industry for roughly 10 years now, both network and application security. I kind of got started in the defense world as a software engineer, but I've always flirted with security and security research, and have gradually kind of flipped my role around a bit. I've been with Veracode about 3 years now, and primarily talk with just our customers, the development organizations, as well as our security organizations, to help them understand the reports, but more importantly, help them figure out proactive and good ways to actually fix software and make more secure software in general.
And not only that, but Matt has a much cooler Twitter handle than I do, so, which is always a reason to have somebody on a talk. So let's dive right in. So as I said, we're talking today about our latest study around the state of software security. This is, by and large, the largest quantitative study of application security risk that's on the market. It's based on data from over 400,000 application tests that were conducted in the last 12 months leading up to the publication of the survey. And those tests represented over 250 billion lines of code. This year's report looks at historical data and trends. It covers applications in a lot of different industry verticals this year, including data around infrastructure. And the report itself comes in two flavors. There's the main report, which has most of the ground truth about what we're seeing in applications and how application security programs run. And there's a developer supplement that we published late last month that really looks at the data from the perspective of development teams and tries to make what we're observing in the applications that are being tested more actionable for development teams to work from. And that's kind of the perspective that we want to look at in the discussion today. Before we dive kind of into the meat of the results, one of the things that's always fun with DevOps.com audiences is I know that we have an audience that has lots of software development practitioners, lots of software DevOps enthusiasts and everything else. But if past experience is any guide, not all of you have direct hands-on experience with application security and maybe haven't spent a lot of time thinking about it. So we want to open up a little bit with the frame of kind of why we have an application security problem and why we think it's relevant to the DevOps conversation before we dive into the data a little bit more deeply. So let's talk about the problem and frame that out with the data that we see. So the good news, and this is not part of the problem statement itself, is that there are a lot of organizations that are embracing DevOps, specifically, more broadly embracing software as a way of achieving competitive differentiation, and with DevOps embracing a way to help them go to market faster and be more responsive to their customers and ultimately to gain competitive advantage, which is a very, very good place to be. The challenge that we see is that in the face of embracing rapid deployment cycles and trying to seek competitive advantage in this way, is the ground truth issue, which is that applications have been for as long as we've been measuring this in the state of software security, and likely will be for the foreseeable future, points of vulnerability for the enterprise. What we know from the data is that software is insecure, and it really doesn't matter who's writing it. It doesn't matter what industry it's in. By and large, the applications that we see have vulnerabilities in them that can be used to compromise the confidentiality, integrity, or availability of the data that the application is protecting. And our methodology for doing that is based on testing. We obviously can't make any judgments about the security of an application before we actually look at it. But the first time that we test an application on behalf of a customer, we use that as our baseline to understand what state was that application in before the customer started to embrace application security and started to think about putting testing in to help to make that control, if you will, part of their process and really understand what issues they had to fix. And specifically, the numbers are 70% of every application that we test fails to pass the OWASP Top 10 policy. And basically what that is there's an industry group, the Open Web Application Security Project, that collects data in an open way and puts together a list of the top 10 issues that are potential security problems for web applications. This report, like the ones before it, is based on the OWASP 2013 standard. The 2017 one was just published, so we'll include that in the next report. But Veracode is a contributor of anonymized data to the OWASP project to support that. So 70% have at least one vulnerability that is blacklisted in the OWASP Top 10. 77% have at least one vulnerability, period. 12% of all applications tested have at least one high or very high severity vulnerability. And here we're talking about things like SQL injection, which allows an attacker to exfiltrate data out of a database. We're talking about command injection, which allows an attacker to run code arbitrarily on the machine that the application is running on, and attacks of that magnitude. So pretty much complete compromise of the asset being protected. So you have organizations that want to go faster that are embracing DevOps to help them do that. You have the fact that applications are broadly vulnerable. You put those two things together, and it's not a great situation, and we can be more specific about the risk. So of all of the applications that we've tested in this year's study, 35% used some kind of hard-coded password. 39% were using cryptographic algorithms poorly, either using algorithms that were known broken or using safer algorithms but in unsafe ways. If you're interested in this topic specifically, there's a great blog series on the Veracode.com blog that talks about how Java cryptography can be insecure out of the box and the things that you need to do to consider it based on some of the things that we've seen looking at our customers. 28% of web applications are vulnerable to open redirect attacks, where somebody can post a link to your application and make it look like to somebody who clicks on that link they're visiting something in your environment where in reality they're being forwarded off to a destination of the attacker's choice. 16% of all applications have boundary issues, basically injecting untrusted data into a trusted data structure, which makes it likely that a developer is going to do something unsafe with the data down the road. So, if you're interested in a kind of a breakdown of the types of risk, there's a lot more data in the report about this. The bottom line and the thing that we want to understand out of this is, number one, there are a lot of different ways that applications can be attacked, and number two, a lot of them rely on errors or misunderstandings or easy to make mistakes in programming by the development team writing the application. These are not things that, by and large, where an attacker is having to invent some sort of way to break into the application without having any help. By and large, they're exploiting some underlying weakness in the application that allows them to gain access. The other thing that we know from the data is that we aren't lowering the waterline, that despite the fact that Veracode has been around for 11 years, that static application security testing, one of the technologies that Veracode has used, has been commercialized for security testing since about the year 2000, maybe a little bit before. And black box testing of web applications has been around even longer than that. We've known about some of these vulnerability categories for almost 20 years, but still we don't see the waterline lowering in a statistically significant way. Year after year, we see that about 30%, give or take, of all applications have a SQL injection weakness in them that could be exploited and could allow an attacker to steal data from a database. And that number just doesn't vary that much year over year. We have yet to see kind of a change in the broader software development culture, which we hope to see someday, where when we start scanning an application, we see much less SQL injection. And that starts to get to one of the root problems that we're going to talk about today, is the general level of awareness that folks have about these types of vulnerabilities and what causes them and how to avoid them. So when we want to talk about the effect of that, you put together kind of rapid development cycles, whether folks are actually doing true continuous delivery through DevOps or if they're just shipping software more frequently, with vulnerable software. There's an outcome that can proceed from that, which is that the data that is being protected by those applications can be exposed and can be stolen. There's a great data visualization that I commend to your attention. Unfortunately, my slide formatting is a little off, but if you go to the website informationisbeautiful.com, they have a number of fantastic ways to visualize large data sets, and one of them is a visualization of data breaches. And in this particular chart, the bubbles are colored according to the what's been publicly disclosed about the method used to leak the information, and the size is the number of records stolen. You can play around with different settings on this. So there's, as we're all aware, a lot of different data breaches that are out there. What's really interesting for the purposes of this talk is understanding what causes them. And as you look at the legend on the right-hand side, they've identified kind of 6 or 5 root causes: data accidentally being published online, data being hacked through some sort of weakness in the application underneath, an inside job where an insider got data that they had access to through their job and then breached it, lost or stolen device. Usually this is backups or laptops that are lost and then expose sensitive data. And then the catch-all for security, which for the purposes of today's talk, we'll assume has something to do with the application broadly. So if you turn off the things that are not application related, if you turn off inside job and lost, stolen device, and accidentally published, or leave those on, and turn off hacked and poor security, what you see is that with the exception of River City Media, which is a weird case where a subscriber database was left online and shouldn't have been, most of the rest of the chart disappears. Overwhelmingly, the data that's being collected by databreach.com, and this is borne out in other sources as well, has to do with the security of the application protecting the data. And when that application is breachable, then the end result is often that there is a loss of the data from that application, and with grave consequences. For one of the bubbles that disappeared there, I think a lot of us were affected when a credit agency in the U.S. lost records of the individuals that it had credit histories for. I know I have my letter from them. So there are consequences, and so historically, what this has led to is a challenge between kind of the broader development community that sees the benefits of DevOps and wants to achieve them, and the security community that has a somewhat more jaundiced view of this brave future. I always like to give credit where due Pete Cheslock, who I think is working at another Boston-based security company, included this slide in one of his DevOpsDays.com presentations, and I have been stealing it from him ever since, because I think it really does illustrate the point, which is it's hard to address the problem as long as there's a misunderstanding of intent, or a level of skepticism or pessimism about the value of DevOps and of doing rapid development cycles. I think that what we think is more helpful and a better way to go about the problem is figuring out how can security groups, how can companies like Veracode help development teams to go fast, but to go fast securely. And that's what we'll be talking about as we get through to the last part of the presentation today. So let's talk in specific terms about some of the data that we saw in the study, and kind of some of the specific things that it underlines that we see in terms of kind of developer, in some cases developer behavior, in other cases developer knowledge gaps, where there's room for addressing some of those to improve the security of software overall. So the first thing that we looked at in the study was the use of open source components. This is a part of the study that we introduced in the 2016 State of Software Security report, and we came back and revisited this in this year's report. And what we know from working with lots of development teams and from the data that we collect is that many applications use open source components. Java, which accounts for the majority of the enterprise applications that we assess, has a lot of open source component use, which makes sense. Open source can often deliver functionality at high quality for little direct cost to the development team to help them go faster. The problem is that open source components can be vulnerable just like any other type of software, and in the data that we looked at, 88% of all of the Java applications that we tested had at least one component that had an open source, that had a known vulnerability disclosed in it. That's dangerous because open source vulnerabilities are a little different from the vulnerabilities that we might report in a developer's own code. When we talk about open source vulnerabilities, we're talking about disclosed vulnerabilities that are published in an industry database like the National Vulnerability Database, and therefore are available to researchers and security teams, but also to attackers, and can be used to take control of large numbers of applications. So this is an area of concern that I think is just starting to be on the radar of a lot of development teams, and security teams have been worried about it for a little while now. Case in point, we had a vulnerability disclosed in a commonly used Java web development library, struts, in 2017 in March. And we looked at the data of what versions of the struts software people were using as of March 2017 when we concluded the data pull for this study. And something like half of all the software versions that were available for struts and that were being used by customer applications were subject to this strut shock vulnerability. We were fortunate or just had good timing to take our data sample just when this vulnerability was being disclosed. So this part of the data set doesn't reflect any remediation activity. But what we learned when we went back and looked at the same data set 6 months later is that there hadn't actually been that much remediation going on, despite the fact that this particular vulnerability has been connected to the breach at Equifax and fingered as one of the ways that attackers were able to get in. And not only did we not see a lot of patching activity when we look back at this 6 months later, but there's also no clear connection between the version of struts that is in use by the largest number of applications here in the study and any sort of currency or, it's not the latest version that people are widely deployed on. It's about, 2 minor revisions back and a bunch of patches, where there have been at least 10 patches issued since the version that 21% of the software that we looked at had incorporated. So, as we look at data like this and oops, skipped ahead, and there are a couple of other case studies that are in the State of Software Security report, we think that we have enough data to say with some confidence that it doesn't appear that developers are aware of open source security risk, and there's a couple of root causes that we go into in some detail in the report. Summing up, basically, it appears very likely that developers often don't know exactly what open source libraries are in the applications that they use. They might have chosen some of them, like struts, but may not be aware that there are other open source libraries used by those components that they chose that are along for the ride. And it also appears that upgrading open source components is just not something that software development organizations do. There's an entire talk that could be done around this topic, and I've given it in the past, so we won't go into too much more detail other than to say there's an opportunity for development teams to do more about this problem simply by being aware when new patches are released for the open source that they're using and incorporating that as part of their regular cadence of software development, retirement of technical debt, and so forth. And that's not the only thing that we looked at. Matt is going to talk a little bit about the next topic, which is the intersection between software development language and the sorts of issues that we find in those applications.
Right. So one of the things that I generally talk a lot on my calls with development organizations about are the flaws that come back from scanning the actual application. So we'll set aside the open source risk, which is definitely present, and look at the application code that the development teams are actually actively working on or touching or maintaining. And when we break that down into language, we get some interesting trends and things that pop out. And so we have there's kind of a busy graphic there, but color-coded and kind of heat mapped to where we see certain problems. So if we're looking at a couple of some very popular flaws that we typically detect, some of the most prevalent in our languages, and break them down, we'll see that pretty much every language is affected at least somewhat, and there are certainly other flaw categories that are not on this table that may impact certain languages more. But if we're looking at this, you'll probably see that Android and PHP are sticking out as being very pink or high risk or high incidence of those types of flaws within those applications. And that sort of makes sense if we think about how those languages are being used and how development teams work. PHP has been around for a while, and some of the earliest web applications that were built on top of that before security was really thought about or baked into development processes. So it's not surprising, at least to me, that you see PHP applications have a higher application risk there. PHP, just as a language side effect, of course, would give you the ability to really directly interact with user data a lot more easily than, say, some other languages, and so that might contribute there as well. Android has some similar things built in. A lot of web applications in particular, when reported to mobile applications, kind of just sandbox them in a web application within the web browser component of an Android app, and so you end up bringing some of those same flaws along for the ride in that case. If we flip it around, though, you can look at something like, say, COBOL and see it has a much lower incidence there. And if you think about how COBOL applications are used and typically deployed within an application, they're much less likely to interact directly with the user. You probably haven't seen a COBOL web application server around, so it makes sense that those types of flaws are missing or downplayed in this case. And then if we look at like .NET and Java, it tends to be those big application pieces that we're seeing. They tend to be in the middle there, and if we're working off of frameworks and so forth, those frameworks have matured to a point where they abstract a lot of necessary work away, and in the process have built in things like automatic encoding in certain cases, but haven't entirely removed that risk whatsoever. And so we may end up in a position where we think a framework or a component is handling something, but that's not actually the case based on how it's used, so we still see those that instance there. So really, I think the takeaway is that not necessarily one language is better than another when it comes to developing your software, but we have to understand what comes out of the box and where your starting point is with those particular applications, and then start from there and building security as we need to on top of that.
Yeah, and I would say based on what has followed in past years as we released versions of this study, we want to be really clear on that point. We are not saying that you're crazy or that we hate your language of choice, for writing in something like PHP or Cold Fusion or something like that. But please do be aware of the security protections or lack thereof that may be in languages that you're using.
Absolutely. One of the other pieces that we looked at when kind of surveying our organizations is what training are people getting as they're developing. And so I know when I started out in software development, I didn't really take software courses, or I wasn't really trained, or software security courses, I should say. I wasn't really trained on the job about the security of writing good software and defensive software. And looking at the data, we're seeing that same trend, right? People are graduating with degrees in computer science and software-related fields without getting any sort of background in security or considerations there, and organizations aren't necessarily providing that up front. And so one of the things I try to do when I'm working with our customers is, in addition to figuring out how to fix what the problem is now, is to teach how we can prevent them from being introduced into the future.
And when we look at kind of the result of all of this, the riskiness of software, more or less generally nuanced by the components that you may be using, the language that you may have written in, and the education that you did or didn't get as a developer. And we can go directly to kind of what's on the mind of developers as they consume the results from a security test. And this was a brand new feature in this year's report that is contained specifically inside the development supplement. We wanted to understand a little bit better what developers do when they get security findings, how they receive them, and how they take action on them. And we really looked at two pieces of that. One was a quantitative piece, looking at the formal disposition of the finding by the developer. There's a workflow that developers can take security findings through in the Veracode platform. That's called a mitigation workflow, and if a developer documents that there's some reason that the security issue is either not exploitable or otherwise not a problem, and usually somebody in the security team signs off and approves that mitigation, then the finding is essentially closed. So as we looked at the data set, 80% of all the findings that came through received no mitigation or kind of other feedback at all. there were about 14% that were mitigated by design, meaning that the developer believed, and somebody agreed with them, that something else in the design of the application meant that this issue was not exploitable. Something like 5% the developers flagged as potentially being a false positive or some sort of error in the Veracode scanner. And then a very, very small fraction were marked as being mitigated by some other control outside the application. Maybe things like memory protection technologies on an operating system or web application firewall rules. So, the first quantitative part of the study basically told us that developers, contrary to the beliefs of most security practitioners that I talk to, are not by and large, saying that every finding from a security test is a false positive. If they're kind of reacting to the finding at all, they may be saying, oh, I understand that this could be a problem, but it's not a problem in my application for a certain reason. The second thing that we tried to do was go in and look for clues in the actual descriptions that were offered by the developers of why something should be not actually exploitable, that were kind of reviewed and signed off by somebody else in the organization. And that was a very interesting exercise. And what we learned as we looked at the results was that between the developer and the approver of the mitigation, sometimes there wasn't a lot of knowledge of the potential attack or the way that somebody could actually exploit the vulnerability. And so, you got things like assertions that because we verified the injection source, it can't ever be attacked via SQL injection, that some other development team is responsible for sanitizing my input upstream, and I'm not going to have to worry about it. And my personal favorite, that this is a web application that has a list box on it. Because the list box provides all the values in the GUI page, nobody would ever modify the values that are there and attack through that means. Matt, I'm sure you've seen similar comments and feedback from the development teams that you worked with. You want to talk a little bit about how you coach people over kind of this knowledge gap?
Yeah, sure. This is one of the biggest topics that we discuss on our calls with development teams and security teams, for that matter, and kind of get at that education of what actually is our attack vector when we're talking about certain flaws, and looking at the application depending on how it's deployed and all of the protections at that level, right? And what we see is that, and even speaking personally, when I think about how I'm developing software, we kind of end up in kind of two perspectives when we're looking at these. When I put on my developer hat, I tend to be in a maker sort of persona, where my goal is to build the functionality as required to make the application work. Right? We care about things like scalability. Is it going to be robust? Are we doing good error handling and so forth? Right? So the functionality is the important part, and we don't necessarily consider how someone might give data input or use the application in a way that wasn't intended. And then when I flip my security practitioner hat on, we kind of look at it from that other perspective, or a breaker mentality, of looking at, given an application's functionality or intended functionality, how can I change the inputs or use it in a way that breaks the assumptions about how a normal developer or user of that service would actually work, and see what the application does and how it behaves. And so if we start transitioning our development into that more breaker mindset and considering those pieces, we might be able to be more defensive and proactive about validating information or encoding or doing whatever is appropriate to make sure the application behaves as appropriate, regardless of how it's used or the data that are provided.
Yeah, and I think that's a really important point. We don't think that developers need to be able to become penetration testers. There's a lot of skills involved in being able to break into an application in a live sense, but understanding enough of the basics of how an application may be attacked so that you can properly defend against it, you can properly leverage the results of automated testing or other types of security testing to make yourself more secure. That's an important piece of the puzzle, and I think that getting that kind of on the job training of interpreting how to interpret security results by thinking like an attacker is a really key and important part of the puzzle. And As we go into this last section, we'll actually see some data that bears that out. So let's talk a little bit about what development teams can do to build more secure code as part of their process of releasing software to the world. And I'm going to talk about some strategy and some tactics, some higher level organizational things that you can work together, whether you're in development, whether you're in security organization, whether you're in IT broadly, to get after this problem and make things work better, as well as some specific recommendations for how to bring application security into your development processes. There are a couple of dimensions to the strategy. One, it's not all technology. A big part of this is relationships and accountability. We will talk about integrated and automated scanning. As hinted by the discussion of the knowledge gap, we'll talk about training and coaching. And we want to wrap up by talking a little bit about enabling developers to own more of this problem themselves through programs like Security Champions and other developer enablement capabilities. When we're talking about relationships, a lot of this comes to the fact that this is not just a problem for security. Security is not just a problem for development. It's really a shared responsibility. Often when we go into an organization, we see silos and we see mistrust between the disciplines. The security person may have no idea who their peer is in the development organization that they should be working with. And development probably only sees security when they're coming around bringing the results of the latest penetration tests or rolling out the latest set of standard controls that the development teams have to implement. So building that relationship is critical. Face-to-face is a great way to build that relationship. And getting beyond just knowing who the other person is, understanding that person's goals can become a really key way to make sure that you're working together to make the organization and the software that you're building safer. And I think that empathy becomes a very substantial part of this. A colleague of ours has talked about presenting at conferences where a speaker comes up and says, we want developers to take accountability. And I think that that's an interesting way of talking about this. It's not asking developers to be held accountable. It's really making sure that there's a shared understanding that there's accountability for the security problem between development and security. And yes, that means that the development team needs to own part of the problem, but also means security has to understand that it's a shared problem and work closely with development to make it happen. You can take that into annual goals and formalize that linkage to make sure that people are aligned, which can be a great first step to making progress across the organization as opposed to just within islands of excellence within the teams that, quote, get it. And it's not worth anything like a lot of things in business unless your progress towards security can be measured and reported regularly. That's a great driver of alignment and of accountability. A key part of the strategy of making software secure, regardless of whether you're doing waterfall, regular agile, or all the way up to DevOps, is to ensure that you're embedding security throughout the process. This is a modified version of probably the most famous visualization of the different parts of the software development process with DevOps. And there's a place for security in almost every stage here. And we'll talk a little bit about some practical things that you can do in each of these stages going fairly quickly. And I want to do that in the context of an example. This looks at the way that one of Veracode's own microservices has structured their development process and how they build security into everything that they do. So that story starts with a backlog, as does every agile development process. Developers take work from the backlog in the form of a user story. They develop code. So far, this is like most other agile development processes. They go on to do some local testing before checking the code in. And as part of that build and test process, they're likely to do some static analysis. And in the case of this particular team, they're doing both full application static analysis on the code that they're doing from within their development environment, sending the application to have kind of a stem to stern inspection before checking it in. but they're also leveraging just-in-time static analysis for the changes that they're making on the code as they're writing it, and getting feedback in seconds if they introduce a security vulnerability inadvertently while they're coding. Once the static analysis comes back clean, they can check in. And they may also do some manual security testing at this point, depending on the scope of the feature. For a bigger feature, that probably is something that will be required if a large new capability is being added to the service. But it's not part of every process, and isn't necessarily a gate that every check-in needs to go through. But on a per check-in basis, this is where the CI pipeline takes over. So from a continuous integration perspective, the code gets built, and while it's undergoing unit tests, it's also undergoing static analysis as part of the pipeline, regardless of whether it was tested upstream before. That might have been a component level check. This is a full application static analysis kicked off by the CI tool. And if the results come back not passing, then very likely the build is going to be broken, and some issues are going to be raised, either just within the UI for the continuous integration tool or in the form of a ticket back to the development team to address the security issues so that they can move forward. Once the build is passing in CI, then the code gets deployed into a QA or staging environment through a continuous delivery workflow. And at that stage, depending on the application, in this particular case, the team was deploying something that had web UI associated with it. So they were doing dynamic analysis, kicking that off via automation as well on their code in the staging environment at the same time that they were conducting other regression testing before finally in this case, this particular microservice wasn't going fully automated all the way through into production. There was a sign-off that needed to be done before it was posted all the way through live into production, and so the dynamic analysis and the regression testing were the ingredients that fed into that sign-off decision. And then it gets promoted on from there. But the point I want to make is that the instant static analysis that we talked about back in build and test happens without the developer thinking about it. The static analysis that happens as part of the continuous integration pipeline happens without the developer thinking about it. The dynamic analysis in the continuous delivery process can happen without the developer thinking about it. It can be automatically kicked off. So there's a lot of ways that we can take some of the drudgery and some of the latency out of the security testing process simply by integrating it into the tools that the developers are already using. We talked about closing the skills gap. We studied two pieces of that in State of Software Security. One was more formal computer-based training or e-learning, where we saw that there was a big difference between organizations that used e-learning and didn't. The magnitude of the difference does vary from study to study based on the applications that are in the study, but every time that we look at this data, we see that there's a positive impact of deploying e-learning into an organization on how many more issues teams are able to fix within the scope of the time period that we measured during the study. The other thing that helps, and helps significantly, and every time that we've studied has proven to be substantial, is remediation coaching. And this is the service that Matt and the team that he works on deliver to developers to help them understand the findings and figure out how to fix them. That allows developers to go much faster and much farther in terms of removing security issues from their code, and we definitely see that in every study that we do, that remediation coaching is a tremendously effective way of closing the knowledge gap. So there's a lot more that we can talk about through all the life cycles of all the steps of the software life cycle. Security doesn't stop when you just get into production. Not all security can be automated. There's a role for things like threat modeling and the impact of security experts in the process of defining requirements when you're figuring out how to take stories into and turn them into code. But the point is that there are a lot of different places that you can start and a lot of things that you can do that if you're not doing them already, starting anywhere on this chart can improve the security of the software that you build. And as you implement more of these habits, as you build more ways of building secure software into the work that your team does, the better that your software will be and the more that you can release quickly, but with confidence, which is ultimately our goal, that your software is not going to be used to expose you to vulnerability. In the interest of time, I'm actually going to skip over that, but the real point of the discussion hopefully has come across that while there are some systemic things that contribute to vulnerable software, there are also some fairly straightforward practices that we have seen hundreds, if not thousands, of development teams implement that have substantially improved the security of the software that they're building. And if you want to learn more about what we are doing and kind of the data behind the discussion that we've led today, if you visit veracode.com/SOSS, that's State of Software Security, you'll see a lot more information from the study, the actual download, some views of the data, some benchmarking that you can do against different industries that you may participate in, some videos to help understand the problem a little bit more deeply. And with that, we're going to stop the presentation part of the afternoon's webinar and open it up for any questions.
Awesome, great. Yeah, so we are taking questions from the audience. So if you do have a question for either Tim or Matt, please use your control panel and put your question in, and we'll hopefully have time to get to them. Okay, the first question is, a lot of our developers are working in Python. Your analysis suggests lower rates of application risk for this language. However, are there any particular vulnerabilities or potential pitfalls we should be aware of?
Yeah, so I mean, the first thing I would say to that is, so every language, again, has some baseline of built-in security mechanisms in place. So knowing based off of what language you have, where that is kind of your first step to it. So when we're looking at Python, though, Python is such a broad language where we're seeing things built at web applications and lots of web application frameworks, which tend to be a little bit newer and may provide things like encoding out of the box. But Python is also used for a lot of scripting or automation or even local pieces. So the threat model there is very different. And so while we were looking at that chart earlier where that percentages might be lower in that case, they're likely higher in others where maybe we're talking about directory traversal or so forth, where the scripting may not be web-related kind of applications.
Okay, great. I got another question here for you. Are there tools, either proprietary or open source, a developer can use to mitigate the security flaw in his code?
Yeah, that's a good question. For mitigation, there's a couple of different things that can be done. Historically, the way that people have tried to do this without fixing the code has been deploying a web application firewall, and there are certain industry standards that recommend that as a mediation. It's not a perfect strategy, and in fact, with WAFs, the knock has always been that they cause a performance impact, which is problematic for organizations that have to process a lot of transactions. And they're prone to false positives. Scripting WAF rules is not straightforward and can cause transactions to be declined that should actually be able to go through. And so a lot of organizations buy a WAF, think they're protected, but don't actually turn on the protection features. There are other technologies, runtime application self-protection is an example of one that tries to leverage a WAF-like approach, but do it within the application context, running actually inside the application runtime. That's very, very, very early stage technology. It's an interesting market, and we're looking at it, but there are a lot of gotchas in it because the protections have to be specific to the application language. There haven't been a lot of runtime application security vendors that have produced something that can defend across all tiers of a deployed application. And generally speaking, weak points include not only mobile clients, which are usually beyond the scope of what a RASP solution will protect, but also in browser code, which is increasingly a problem as lots of web applications move much of their business logic and their actual operation into JavaScript that operates within the client's browser context. So there's not a really good perfect answer. From an open source perspective, we don't see a lot of options out there either. There are starting to be some open source detection tools. There's a few for static that are language specific out there, and there's at least one open source dependency identifier that I'm aware of. And I would say that if you're not doing anything and you don't think you have budget for commercial tools, start with open source because it's a lot better than doing nothing. Eventually you may want to standardize on something that can provide you results across your whole portfolio of applications, and that but I would much rather see an organization start with an open source tool than not do anything at all and then get hacked. So.
All right, great. Okay, we've gotten a bunch of questions in, so but there is time. If you do have a question for Tim or Matt, please go ahead and get that in, and hopefully we'll be able to get to it. Our next question. Okay, so let's see. It says, why would you think awareness is increasing? The SOS report, State of Software, so the report shows 30% in the waterline slide shown in the beginning.
So I want to draw a distinction between some of the data in the report that we look at from a perspective of an application that we're testing for the first time, and what we see in terms of general market awareness of the problem of application security. So, by definition, when we test a lot of the applications in the study, we are looking at them in their raw state, in their kind of before the development team has been exposed to any formal application security testing practices. Maybe they've tried something else and failed, but by and large, the application hasn't been tested for security at all. And that's what I would like to see over time is that even when we are testing applications for the first time, that that there's been enough awareness in the general industry of the problem that just because it's the first time that somebody is testing with Veracode doesn't mean that they don't know something about application security, and that the application has reduced the inherent risk even before they come and start testing with us. That's not what the data shows right now. So it's a future that we aspire to. We hope that by continuing to educate the market, by continuing to work with developers and make people aware of the problem, that over time we could see that chart go down. But that's not the world that we're living in today, and that's what the data suggests to us.
I can say anecdotally, maybe this is a kind of a future research for us to look into, is that the teams who have started scanning with us and are using my team to talk through things and going through some of the trainings we offer, we do see some of their newer applications as they're onboarded and scanned, the open rates of those flaws are much lower on those later scans, and they're much faster at fixing the flaws when they're identified because they have that experience.
Yeah.
All right then, great. Next question, can you make some suggestions for integrating automated and manual code reviews for enterprises that utilize different development processes such as waterfall as well as agile, which can be quite different when trying to assimilate different security processes?
Yeah, that's a great question. The ability to do automation around this testing is a little bit dependent on your embrace of automation in your development process generally. So, if you're not doing continuous integration, then using a continuous integration server as a way of doing automated security testing is not a no-brainer. That said, it's not hard to set up a Jenkins server and use it to just run processes, even if it's not automating all of your builds. And in fact, I've seen some customers who are using Jenkins jobs not for no other reason than to actually kick off automated testing on a schedule. And so that may be one way to think about it. Another way to start, if you're an organization that has not embraced continuous integration yet, is to start with the developer. If you give a developer an IDE-based tool that lets them get some rapid feedback, A, it's better than nothing. B, just as Matt said, with respect to teams that kind of go through an education process, introducing fewer issues later on, we also see teams that use instant static analysis tools. Veracode has one called Greenlight. Organizations tend to introduce lower volumes of vulnerabilities later in the process, kind of by and large, once those tools are in use. We've seen that in a couple of case studies. We're looking forward to making a broader study of that in the next State of Software Security report, but that can be a good way to do it, to do security testing in an automated fashion, because it happens when the developer saves their code. It doesn't require them to do anything else. Beyond that, it's possible with the APIs and with the tooling that can be provided around kicking off static and dynamic tests, to just write a little script and set it on a timer on your server to go through and upload the latest version of your code. None of this needs to be hard. It just, CI makes it a lot easier, but even without continuous integration, there are a lot of options for automating software testing as part of your process.
Okay, great. Quick time check. We're about 4 minutes to the top of the hour. I think we have time for 1 or 2 more questions. But if you do have a question, send it along to Tim or Matt. Just send it along using the control panel. Next question we have, any open source static analysis tool that you would recommend in the microservices world?
That's an interesting question.
Yeah.
Well, it's interesting for a number of reasons. One is that we see some open source static analyzers that are starting to be pretty good for quality issues. A lot of people use SonarQube for quality testing. We don't see as many of them that seem to be really good at finding security issues, and that can be a combination of things. One is, that most of the open source tools that I'm aware of have a relatively limited scope of security issues that they cover. But the second one, which can be really important in enterprise development, is that for static analysis, you have to have a really good understanding of the data flow and the control flow in the application, or else you won't know what's going on in the code, and you won't be able to figure out whether an issue is exploitable or even what the application is doing. And that gets very complicated if the developer is using a framework for development that plays with data and control flow in interesting ways, which most of the frameworks out there do. So if you've got a static analysis tool that doesn't have an understanding of the framework that's being used, whether that's to facilitate microservices development like Spring Boot, or just to make things easier to deploy, something like an OSGI sort of pattern, then the tool's not going to return good results. It just won't understand enough of the context in which the application is running. So I can't give specific recommendations because I'm not aware of tools that do a good job for this, but I would recommend, as you're evaluating static analysis tools in particular, looking not just at the languages that they cover, but also the frameworks that they can provide support for, and how new frameworks get added to the application, how frequently the static analyzer gets updated to provide new coverage, are really important if you want to make sure that the tool will continue to support the needs of the development organization that you're working with.
Okay, great. Well, I think that's going to be it for today's questions. Unfortunately, we had a lot of them, and I know we didn't get to all of them, but I'm sure that the fine folks at Veracode will be more than happy to follow up with you guys post-event if your question was not answered during today's event. I do want to remind you guys that today's event has been recorded, so if you have missed any or all of the webinar, please know that you will be receiving a link via email to the webinar on demand. It will also be on the DevOps.com website. Also check the DevOps.com website for tons of other webinars that we have coming up. Hopefully there'll be 1 or 2 or 3 or 4 that pique your interest there. I would like to thank Tim Charrett and Matthew Runkle for being such fabulous presenters today. Thank you, gentlemen.
Thank you.
Thanks a lot.
Great. I hope everybody has a nice holiday season. And for now, it just leaves it for me to thank the audience for joining us. And this is Charlene O'Hanlon signing off. Have a great day.